Hi, buddy. This is Mr. Folly again, and welcome to part two. Oh boy, this is going to be some fun podcast, I think. Where now we're going to pick up where we left off, talking about Hess's law. Now, Hess's law says it doesn't matter how you get there, just that you get there with heat. So it doesn't matter what direction you get. If I start here and end here, the process is just a difference here, even if you go up some, down a little, up a little, and then all the way down from here. So that's it. So version 1 is products minus reactants. And version 2 is add and subtract step reactions to get the final reaction. So the delta H the products, which we get a table that has these things on there. And delta H the reactants, which again, those numbers come from the table. And then step 2, I think, is what we're going to start with. Version 2. As odd as that sounds. Oh, no, we won't. Version 1. Find the delta H of the reaction given the following reaction data. So remember, it's products minus reactants. So delta H equals my products. There's two of these, 2NO2, so 2 times 34 minus quantity NO, 2 times 90 plus, now oxygen's not here, so this is important to know. Delta H, a formation of elements in their standard state, equals 0 kilojoules per mole. Okay. Other things take energy to be made, but we say elements are baseline of 0. So if I have oxygen here, I'm going to say plus 0. And then this would be 68 minus 180, which I've had such bad mental math, I will go to my calculator, which is a shame, but what are you going to do? And I get negative 112 kilojoules per mole. That's it. So if I were to do SO3 plus water yields H2SO4, I would have delta H equals products, H2SO4, negative 909. Notice bigger compounds take more energy to make. They actually release more energy. Minus reactants, SO3, negative 396, plus, and again I'm adding these, water, just negative 286. Now, I notice there are no coefficients, so I'm going to check to see if this is balanced. 4 oxygens, 1 sulfur, 2 hydrogens. I'm a believer now. So now that I have my calculator out, negative 909 minus quantity, negative 396 plus negative 286 and quantity, and I get negative 227, which is a really bad TV show in the 80s. Maybe it's a good TV show, not quite sure. Delta H element at standard state is 0, which is what I just said. Standard state of oxygen is O2 gas. Standard state of phosphorus is P4 solid. Standard state of sulfur is S8 solid. Aren't those crazy? They're so crazy. Version 2. Use the following data to calculate the standard heat of formation of ICL in kilojoules per mole. So ICL is I2 plus Cl2 makes ICl. Now, the standard heat of formation means I have to make one of these. So if my goal is to make one of these, I need half of this and half of this. So that's my overall goal. So what I'm going to do is I'm going to try and make ICL first. So I look for ICL, and I see that I have to flip this. And that will give me I gas plus Cl gas yields ICL gas. So I've got this part done. Now I need to have half a chlorine on the left. So I'm going to put this part right in there. So I'm going to do, and I flipped that around. So if I flipped it, it's negative 211. Now I'm going to do half of I2. 1/2 of I2 yields I. Okay, so I divide that in half, I'm going to get 75.5. Oh, don't freeze on me, don't freeze on me. Good. And then if I want chlorine, I want half a chlorine. Oh, I just did that, didn't I? Oh, well, whatever. I want half a chlorine, so I'm going to do half of Cl2 is going to give me Cl gas. Okay, now if you notice, I've got this state of matter thing going on here. So I2 gas, but I2 is a solid when we start with. So notice this is my gas. So what I have to do first is go with I2 solid to I2 gas. And notice I didn't change anything there. So that's positive 62.9. And half of chlorine is positive 121. That's not writing, but you can do that. Then what you do is you add all that up and you get your answer. Hello, people in Science Olympiad who were early. You're my favorites. Let's hope the next one will hop and go to the next one. Come on, come on, come on. Oh, no. Well, maybe page down will do it? No, 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 no. Oh, well, hopefully you can do the math. I am officially quitting this, and we'll make do with what we have for tomorrow. So there will not be a part 3, so there is a part toodles. Adios. Bye.